It's a really specific way to do this. And then the third thing that I love and that is actually relevant now more than ever is while we are collecting all of this information per plant, now we're talking about big data because you're collecting information per plant, but it's per farm, per area, per region. And if we have a farm in Nigeria, a farm in Zimbabwe, a farm in France, a farm in Ohio, America, a farm in China, the weather patterns are going to be completely different across those globes, and we can aggregate to train models that can better really learn more about this plant signaling across, because the same type of plant, it's the same crop, right, all across, same chip, same hormone we're detecting, just different environments, different plant farms, different weather systems. And so we get to learn quite a lot in one go, especially with the cloud information and whatnot. And so this was the big idea that I had, and you can see why people threw money at me. And I had not a prototype, but I had a scaffold, scaffolds that we just talked about, and I showed the molecule that I made. Actually, I have that molecule here. But Lawrence, what do you think about the binding idea? Tell me about, do you think about the de novo protein idea?
Amazing. I love it so much.
Yeah,
So
this is
give us
great.
the protein. Give us the protein, all right? So we'll see if other proteins are bound to it. So we just want the protein. So if other proteins are bound
That's
to
the
it,
thing.
we'll
It's not
truncate
a
it.
protein. You have to make the protein, but the hormone is not a protein. The hormone is a small molecule. So you have to make a protein that
Okay,
is
okay,
a small molecule.
okay. One of the proteins that binds to a small molecule. That's ligand MPNN, right? Yes.
You can use ligand NPNN, but you can use Rift Dock is another one that's out there. You can do docking systems. But this is the protein we were looking at in VR. I have a 3D printed model of it. And so the idea, and so this is the one that I was showing during that time and pitching, is that we basically had the scaffold, and what I'd been doing was carving out a hole. Remember, I showed you guys there's no hole here. It's all hydrophobic interactions. So I'd been carving out a hole here so I can then dock the small molecule there, and it would fit potentially there. And so I think when you start designing this, I think now with all these tools, RF diffusion, you don't have to start with known backbones, right? But I think as you start pruning out different backbones, focus on ones that have beta sheet type topologies, because this hormone actually has its own native binding partners, and that natural binding partner actually has this similar shape. It's a really wide beta sheet type topology. And so if we want to learn from nature, we should definitely learn about that binding partner, right? I think as a prototype, we could even just take that actual natural binding partner while Lawrence and McGregor are going in parallel to make a de novo version, right?